A rock that costs under $1 kills 94% of E. coli and strips 97% of arsenic from contaminated water with no filters, no chemicals, no electricity. Civilizations relied on it for 4,000 years. Then in 2008, the EPA quietly classified it as a pesticidal device, while a $35 billion filter industry sells you cartridges that expire every 60 days. So where did this knowledge come from, and who buried it? In the shadow of the pyramids, a vessel dated to 2400 BC sits in a glass case, its surface marked by the passage of centuries. Archaeologists studying Egyptian water practices point to texts describing the use of alum and iron sulfate to clear Nile water, chemistry that mirrors the reactions behind modern iron mineral purification. Yet when pressed, museum records show no direct mention of pyrite or flintstones being dropped into jars for drinking. The iron-rich beads found in tombs, often meteoritic, were prized for their otherworldly origins, not their utility in water. An Egyptologist paraphrases that the ancients understood how to settle mud from water, but the stones themselves were symbols, not tools. Across the Atlantic, oral histories from Native American communities recall rituals with sacred stones, smoke, and herbs. Ethnographers document the use of sand and smooth river rocks to strain out silt, a method still taught in survival circles, but the specifics vanish under scrutiny. No peer-reviewed study or artifact ties pyrite or flint to the deliberate removal of bacteria or metals. The closest parallel appears in the Maya city of Tikal, where zeolite and quartz filtered ceremonial water, a practice confirmed by residue analysis. Yet, in North America, the sacred stone remains a spiritual object, not a proven filter. Roman legionaries, famed for their engineering, left behind manuals detailing sand filters and iron salts used to treat water for thousands on the march. But neither Vitruvius nor the archaeological digs at frontier camps reveal pyrite or flint as standard issue. Legion field kits contain iron for weapons, not for purifying the camp's supply. An archaeologist specializing in Roman sanitation remarks that the evidence for mineral-based filtration is compelling in principle, but the record stops short of naming the stones. 3 continents, 3 timelines, and the same unanswered question. If the chemistry works, why does the historical record fall silent on the $1 rock? The pattern is clear. Ancient societies knew the principles, but the direct link to pyrite or flint as a water purifier remains an enigma. That silence, more than any artifact, begs to be explained. Inside a university chemistry lab, a beaker of cloudy water sits on a stir plate. Into it goes a handful of crushed iron pyrite, fool's gold, the same mineral found in riverbeds across the world. As the mixture swirls, the reaction begins. Oxygen and water convert the pyrite into ferric ions, which quickly start binding to bacteria and heavy metals suspended in the liquid. The science is simple, but the results are anything but ordinary. In controlled batch tests, crushed pyrite at a dose of just 5 grams per liter and a pH adjusted to 4.5 delivers a 94% reduction in E. coli after 20 minutes. That means nearly all bacteria wiped out without a single drop of chlorine or a plastic filter cartridge. The same setup pulls arsenic out of solution with ruthless efficiency. At pH 5, laboratory protocols show a 97% drop in arsenic levels, bringing contaminated water below the World Health Organization's safe limit. These numbers are not guesses. They are drawn from peer-reviewed studies and confirmed by university labs from Iowa to Shanghai. A chemist reviewing the data explains that ferric ions from pyrite act like magnets for contaminants. They clump bacteria and metals together, then settle them out. It is the same basic chemistry used in municipal treatment plants, just stripped down to its rawest form. The process works best in acidic water, and the finer the pyrite is ground, the faster it acts. But even with hand-sized chunks and no electricity, the effect is visible. A dramatic clearing of muddy, polluted water. There are caveats. The pH must be low for maximum effect, and the reaction slows in cold or stagnant conditions. But under the right setup, A $1 mineral outperforms many commercial filters in the lab. This is not survival folklore. It is chemistry, measured and repeatable. The numbers alone are enough to catch the attention of regulators and corporations alike. Federal paperwork has a way of turning chemistry into controversy. On October 22, 2008, the Environmental Protection Agency published a rule in the Federal Register that changed the fate of a $1 rock forever. The text is blunt. Any iron pyrite device marketed to reduce bacteria or heavy metals in drinking water would be classified as a pesticidal device. That single sentence set off a regulatory chain reaction. Anyone hoping to sell pyrite for water purification now face the full weight of pesticide law. The process starts with Form FD 717, a registration application that comes with a $1,150 fee for each device type. 5 years later, another $200 is due for renewal. But the paperwork does not end there. Applicants must submit a stack of data, 30 days of efficacy and safety tests, toxicology reports, and a product label dense with warnings and disclaimers. The label must state, in the EPA's own words, that the device is not a substitute for proper water treatment where regulatory limits apply. An internal EPA memo from 2007, later released under FOIA, lays bare the logic. The memo explains that classifying iron sulfide minerals as pesticidal devices will close a regulatory loophole that could otherwise allow untested, potentially hazardous materials to enter the consumer market, thereby protecting public health. The memo never mentions the $35 billion filter market, but it does highlight a risk that cheap mineral products could undercut established brands and obscure efficacy data. The result is stark. Selling a $1 rock as a purifier now costs over $1,000 in licensing and lab fees before a single sale. The path for grassroots or do-it-yourself distribution is effectively blocked. In the eyes of the EPA, the same chemistry that clears a beaker in a lab becomes a legal liability at the checkout counter. 3 major water filter companies, Culligan, 3M, and Pentair, did not sit idle as the new rules from the EPA threatened their market. In the years around 2008, their combined lobbying spend targeting water treatment standards and consumer product safety reached $2.4 million. Senate records and bill references show a clear pattern. These companies push for stricter definitions and higher regulatory barriers for any new mineral-based filters, including pyrite. Inside Culligan's own files, a 2005 memo lays out the company's calculus. The document warns that iron-rich minerals like pyrite could bring inconsistent microbial reduction performance and trigger consumer liability. But the real concern is spelled out in the recommendation. Culligan should pull marketing dollars away from anything labeled natural mineral and double down on activated carbon and polymeric membranes. In a separate research and development briefing from 3M, pyrite is ranked low feasibility due to pH control and corrosion risks. That assessment was quietly circulated among senior executives, then echoed in public statements touting the superiority of engineered filters. The effects ripple out to the shelves. Market Track retail audit data from 2004 to 2009 documents a 90% drop in pyrite water purification kits stocked by major outdoor retailers. Category managers cite risk of contamination claims and insurance pressure for products without EPA registration. Overnight, the $1 rock vanishes from the aisles, replaced by branded filter cartridges with 60-day lifespans and recurring price tags. The message is unmistakable. If you want to clean your water, you will need to buy in again and again. The $35 billion filter industry has protected its turf, not only through chemistry and engineering, but through policy, paperwork, and the quiet removal of alternatives. A single chunk of iron pyrite, crushed to gravel or powder, is all it takes to start. For a typical emergency batch of 1 liter of contaminated water, measure out 30 to 50 grams of pyrite. Rinse the rock to remove dust. Use a hammer or heavy stone to break it down. The finer the particles, the faster the reaction, but even rough gravel works in a pinch. Drop the crushed mineral into your water container and stir well. If sunlight is available, set the jar in direct sun for at least 30 minutes. This step helps drive oxidation, speeding up the release of ferric ions that trap bacteria and heavy metals. After 30 minutes, let the particles settle. Carefully pour off the clear water, leaving the sludge behind. For safety, use a simple coliform test kit, widely available online, to check for remaining bacteria. If the water fails, repeat the process or boil the water as a backup. No plastic cartridges, no recurring costs, just a $1 rock, a bit of sun, and a test strip between you and clean water. 6 years, 12 cartridges, and hundreds of dollars. This is the silent math behind most household water filters. At $50 a pop, the typical family spends over $600 just to keep the tap safe, swapping plastic cartridges every 2 months as the industry intends. In the same stretch of time, a single chunk of pyrite bought for less than $5 can do the same job, no refills, no plastic, no subscription. The cost gap is staggering, but there's a catch. While pyrite can trap bacteria and heavy metals, it won't stop viruses on its own. Even so, the numbers don't lie. The so-called $1 rock is a direct threat to a $35 billion business model built on endless replacement. The question is, who really benefits from keeping that option off the table? A $1 rock purifies water, removing 97% of arsenic and 94% of E. coli. Yet billion-dollar lobbyists and federal rules keep it off shelves. As filter cartridges pile up, so do profits and barriers. Who gains from ignorance and who pays? Sometimes the simplest solutions threaten the biggest interests. Share your thoughts below.